Hi, everyone, and welcome to the MLOps podcast. I'm Dean, your host. And a quick note before this episode, we had some difficulties with the video recording, so even in YouTube, this is going to be an all audio episode. If you want to catch it in the regular only audio version, we have that on all the podcasting apps. That's it. Enjoy the episode. See you around. Hi, everyone, and welcome to the MLOps podcast. I'm Dean, your host, and today I have with me Jeremie Dreyfuss. Jeremie is a data science manager for AI solutions at Intel. He's overseeing the development of AI projects and focusing on solving mission-critical problems for the hardware and validation teams. He also holds a master's degree from Tel Aviv University in computer vision. Jeremie, thank you so much for taking the time to speak with me today.
Thank you for having me, Dean.
Awesome. So tell me a bit about what production looks like for machine learning, of course, at Intel.
Okay. So first of all, there is no one production for machine learning at Intel. I work at the AI solution groups. We're a department of about 280 data ML practitioners, data scientists, product manager, and we have a various number of projects. Some of the projects, one of the teams focuses on machine learning algorithms that are embedded in the hardware itself. Like if you bought a Alder Lake Intel computer, it has some AI components. So there, the productization is like you develop the algorithm, and then you have hardware engineer looking at the ML model, and you work with them, and they have to translate it into like low-level machine code, right? If you look at some of the projects I've been working on, our production system is we get terabytes of data every week about tests that are running and checking that the chip that is being developed is working well. And we take this data, we like with Spark, and we massage it, train our model, make prediction about what's the best test that you should run next to help identify bugs. And then after we made this prediction, basically the model itself that we train and the prediction themselves, we throw away. Okay. You have some other teams that, train a model, have like proper inference services, and model is in the air, deployed in an endpoint that's being constantly inferred against in the factory, for instance. So we really have a wide variety of what production looks like at Intel, especially in my department.
Fair enough. That's it's fun, I guess, that you get to work on such wildly varying modes of deployment. I guess
Mm-hmm.
there's a few questions that are interesting in for each one of these things. I don't know. By the way, is one of the three more common than the others, or would you say that they're equally
Yeah.
worked on?
So for me, the most common one was like train a model, use it once, throw away, right? I was working with Spark, but today with like a lot of my work involves LLMs. We've opened new activities, so a lot of the work is like, okay, either you use open source models, and you create a inference client and infer against them, or you use like a closed source API from one of the big vendors, and then all the secret sources about your machine learning workflow and your prompts and all the infrastructures around.
Okay, so many things to ask follow-up questions on. Let's start with the things that you had before LLMs, then maybe we can talk about the shift. But
Sure.
for large scale like Spark processing and things like that, obviously the tests that are being run on physical devices. But
Hmm.
from what I'm usually familiar with, when you work with Spark, that usually means large scale tabular data. So can you
Yeah.
share a bit more about like how the data is collected from where, and then how is it used in the end to improve the testing?
Sure. So one of the big challenges here was that the engineering teams at Intel, the ones that do the testing, work there like for years. Before we arrived, they have a process in place. So
Mhm.
the data collection, putting the data collection in place, first of all, was one of the challenges. So we created APIs on our side and APIs on their side where they could send us the data from every test that they're running. It's actually pre-silicon and post-silicon. So some of it is not physical tests, but it's
Mhm.
a simulation of how a chip would work. And yes, they send to us like messages with ton of data. So each test itself is like still manageable. It's a few megabytes of data, and we parse it on our side and save it in a Hadoop cluster. But the thing is, there's like hundreds of thousands of tests being run by one team at Intel every week, and we work with hundreds of validation teams at Intel. So the data collection infrastructure is challenging in and of itself.
Interesting. So in this case, they deliver the data, and from what you're saying, because the sort of inference is a throwaway, right? So you run inference and
Mm-hmm.
you return the result. That does that mean that they also provide you with a specific query that they want to get an answer on, or is this like a standard structure where they give you data from tests and then you say like this is the next test you should run?
Yeah, so it's a good question. Like we have on a weekly basis several goals that they want to achieve. They want to see that when they run tests, they've hit, all the interesting areas of their code, so to speak, all the interesting workflows, and they've hit them enough. So one of the things that we do, we automatically identify areas that they've hit, but hit very poorly. Okay, they've hit like only, let's say, between 2 to 10 times, right?
Mm-hmm.
And from our perspective, these are areas of the code that haven't been fully tested. Okay, they use statistical testing, semi-random tests, so it's quite different from software testing.
Mm-hmm.
And then you can really go and by stressing these area, identify maybe suddenly a test that you would generate will identify a bug. One of the other things that happen is that sometimes they have tests that fail, and what we're trying to achieve is like stress those areas. So if you have one test that failed in that area, clearly something's wrong. Okay.
Mm-hmm.
And one of the validator that I was speaking with a couple of years ago told me bugs are social animals. If you found one, you'll probably find more. So one of the our approaches is to try and target those areas. So we have several layers of intelligence. One of the layer of intelligence we've created is identify what are the interesting target to run and to attack this week. Okay.
Mm-hmm.
And then once you've identified the target and marked them, okay, let's try and create tests that would be able to attack those areas of the code. And then because the resources are limited, you want to say, okay, I can only recommend on a certain number of tests, build the optimization mechanism where I take the recommendation I created and build a minimal list where I achieve all my goals. I'm greedy. I want to do a lot of things, but obviously I can't afford everything. So I would optimize on the list of all my goals to achieve the maximum amount of those.
Okay, so if I'm translating this to the areas that I'm more familiar with, this is like trying to predict which tests are going to yield the highest test coverage for the devices, right? So, like least
Yeah,
amount of tests, highest amount of coverage. Uh,
exactly.
okay,
Okay.
nice.
So in
Yeah.
software, you can imagine something like that being interesting if you want to save on cloud cost, right? Or you want to increase the speed of turnover.
Yeah.
Um, so, for instance, one of the things you can do is Well, if an area of the code hasn't been changed, right? So there's no point in running the tests that usually stress this area of the code. And comprehensive, on the other part, if you know that you have a test that's very good at targeting a specific area, and you know that area of the code has been changed, then you have a high level of confidence that if you run these tests, you either find a bug or at least increase the confidence of the validator that they've done a good job this week.
Okay, fair enough. So one last question about this flow, maybe before we talk about shifting to LLMs and things like that. You're basically saying that the the inference here is a throwaway.
Mm-hmm.
How come? Like, why isn't there a standard model that you can use all the time? Why do you need
Yeah.
to retrain the model and then throw it away? I think that's interesting.
So it's a good question. It's basically because we're trying to hit a moving target. So the weekly tests that are run on a specific version of the model of the code, right? But this is a living and breathing organism. So
Mm-hmm.
every week the designers are designing away and changing the RTL code, the hardware level design. And now the validator need to be able to cover most of the code and be able to identify the bugs. So you can think of it as a stochastic process that constantly changes its distribution.
Mm-hmm.
So there is an element of, okay, maybe last week's data is still a little bit relevant, but 2 months ago's data is clearly not relevant because if I have a test input that is being run on a system, the whole, because it's a semi-random test generator, the whole system will behave differently. Because on a certain week, suddenly they've turned on a certain feature, so the whole chip is going to behave like in a new way. You know, you have something called branch prediction that try and predict where the what's the next calculation that's going to be done. So if for a certain week they've turned it off, suddenly the whole CPU behaves differently, and the test will react differently.
Okay, so the main reasoning is basically that because the data changes too much. So it's not
Yeah,
necessarily that the model itself, the architecture that you're using changes at all, but you just have to retrain every
yeah.
week or so because the data is changing.
From my perspective as a data scientist, I actually don't do anything. So it's still, you can think of it as still a deployment system. Okay,
Yeah,
it's not. I've deployed the model into production because I've deployed my algorithm. I've deployed the code that's implementing the algorithm. And it's running automatically. The data comes in automatically. The model is the training is triggered automatically, and the inference in the same way. And we send the recommendation to the customer, and he runs them whenever he runs them.
yeah, yeah. No, I think that's interesting. I had a few discussions on this podcast about like how do you define production system in machine learning, and I
Mm-hmm.
like that this is like a good example of sort of thinking outside the box in the sense that it's not a model endpoint that you run inference against, but it's
Right.
like an actual ML system that has a bunch of moving parts, including like ongoing data ingestion, retraining, and prediction, that you're deploying that entire system. I'm
Yeah.
curious, like, first I have two questions. One is, was it clear in the beginning when you started working on these things that this is the way the system needs to work? And two, if someone is listening and they need to deploy a similar, let's call it an ML design pattern, right? So they don't need to
Mm-hmm.
deploy a model, they need to deploy an entire pipeline that does retraining. Can you give them one or two tips on maybe counterintuitive stuff that you had to deal with that they can maybe save them time and the pain?
Sure. Um, so in terms of how it was at the inception point, um, it's a tough one. First of all, I wasn't there at the original inception point of the team. The team has started working on this like 7 years ago. I joined the team 5 years ago, but it has evolved a lot over time in terms of the infrastructure, the even the language. Originally, the whole system was written in Scala. We moved to Python at the point where we realized that to introduce new algorithm, new changes, it's just much more efficient if the data scientist who is well versed in Python can do the changes. Okay. Um, so in terms of the system itself, yes, it also changed because the technology has changed, right? Uh, um, uh, the Hadoop cluster infrastructure changed, and we added the messages system, Kafka and things like that. And recently, we've added another layer, something called data lake. So it aggregates the data as it come in, and then you can create like a clean version of your data. So even if something fails and you have to rerun, you don't have to rerun from scratch. So you can save on compute. And this is also like very interesting for development of new algorithms. Because
Mm-hmm.
suddenly when I do my analysis, right, I usually take it from production data. But if I have the Delta Lake infrastructure in place, so a lot of the calculation that I would do at runtime were done once. So even if like I have actually 10 algorithms that are going to run on this data, instead of redoing the whole compute, the whole data preparation 10 times, I'll do it once. And then all these different algorithms, the one that are targeting different moving targets, are going to be reusing that infrastructure and get value from it. So in terms of tips, um, when you have so first of all, when you introduce a new system, okay, um, try and understand what is the minimal amount of work that you can do with that system to get value. Okay, take Delta Lake. We originally had huge plans of wow how we're going to use it and it's going to be amazing, but every new infrastructure that you introduce is painful. So you can either go and solve all the problems and make it work properly, and then go and develop the application layer. And even though we're used to agile thinking for years, it it doesn't always translate when you build infrastructure. So
Yes.
also on the backend side, you need to think, wait, where is the most important feature I can build on top of it? And do I need to build the whole infrastructure? I can build a part of the infrastructure, get value, and then translate. So we went too far on one side, but we managed to correct. And at some point, we said, no, we're not going to build the whole thing. We're going to start implementing, changing our algorithms to make use of the new infrastructure already. The second tip I would say is monitor, 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 and add indicators. Because when you have a system that's supposed to run automatically, then you tend to say, well, it's automatic. I have my triggers, the API calls, and everything, and I see that the system runs or it doesn't, and then I'm going to go and start debugging it or start, developer is getting a call at 11 o'clock at night, production is down, what's going on. But if you have the right monitor, you can see that suddenly storage is going up. Why? Well, because customer misconfigured his data, and suddenly the API is changed. Instead of sending messages of, I don't know, 10 megabytes, he's sending us messages of 10 gigabytes, and it's completely exploding our system. So the having the right monitors in place, the right safeguards, will save you a ton of headache in the future.
Yeah, I can't agree more. I think that in general, this is more ingrained in classical software teams than it is in
Mm-hmm.
data science teams. But I think that when you get to production, especially production at scales like the ones you're talking about, you sort of have to adopt more of that mentality. I think at DAGSA, when we have a new bug, that we weren't aware of, and it's like an infrastructure bug, so not like not something that's immediately traceable back to some line of code that we changed recently. The first thing that we add is a new monitor for that issue, so that we know when it happens.
Right.
And I think that's really important, and it's maybe clear to people in software. But as you say,
Hmm.
like when you're messing around with data, there's a lot of other monitors that you need to add that you maybe not you don't they're not as intuitive to add in software, but you need to know them in this case as well. So I like that. That's a great tip. Um, I guess you also alluded to the change in sort of the responsibilities and focus points. Obviously, LLMs are a big deal right now,
Yeah.
arguably for good reasons. And everyone, I think, is racing to incorporate them into their products. I think there's a bunch of charts, but one of them was if you have um, AI in your product, that gives you double the multipliers, right? In the public market. So it's meaningful things. At this moment, it's making a big deal. I'm curious, like, how do you see the shift? Both like your personal opinion about what's going on with LLMs, and then how do you see that impact on the work that you're doing?
Sure. So first of all, I love LLMs because I love NLP, right? A lot of my work, even prior to Intel, has been in NLP-based startup and NLP-based teams. And I just think it's so much fun to work on them. Um, the In terms of value, yeah, it has made a lot of change in our department, right? We had to make a decision. We have a lot of projects. What do we do with this new technology? How much of the people do we shift? I think each team made a slightly different decision in terms of the percentage of people that shifted to LLM. But even at the departmental level, right? We identify that you've increased your total available market dramatically, right? Before, there were certain things that we could do. Most of our business lines, the team that are specialized with one business unit, they're very at the center of what that team does. But the interfaces between teams weren't covered because a lot of them happen, in unstructured way, emails, documents. So going into NLP classical model was always a bit of a pain, and the ROI, of like training a BERT model to be able to identify something, problematic in hardware document, it would have taken time. Okay, I've had experience trying to train models to identify bugs in code. Okay, with even good transformers and graph neural network, and it was barely working. Okay, we had to scrap the project because, well, the recall was good, but the precision was so bad that no one would look at your recommendation. You're making too much noise, right? So we didn't
Mm-hmm.
even take it out of the research phase. And then, we took StarCoder out of the box, and we with a bit of prompt engineering, we got the same result as ML models that we train on our data for a couple of months. Was a big deal.
Yeah.
So yes, there's a lot of shift, especially in my team, because suddenly a lot of things is possible with LLMs. Will the pendulum swing back? I think so, because at the end of the day,
Interesting.
once you've reduced the pain point in a certain area, then you always have to ask yourself, what is the biggest impact I can give? Today, the biggest impact I can give is by solving the problems that LLM can solve, because they haven't been addressed for years. Now,
Yeah.
or sorry, in the future, the pendulum will swing to a different thing where they say, well, no, what we need is machine learning prediction in the fabs and it's completely structured data, and go back to that.
Sure. Yeah, I like the focus on business value as the deciding factor. I think that this might tie into my next question, but I've spoken to a few people in very large organizations like Intel. I think that um, prioritizing is always hard, but it's maybe hardest when you're in a large organization and there's a lot of moving pieces you might not even be aware of. You mentioned
Mhm.
that every team made slightly different decisions as to related to how many resources to allocate to LLMs.
Right.
Do you have any sort of mental model or algorithm if someone else in a in a large organization is also thinking about that, like how did different people make these decisions?
I think the in the wider Intel community, suddenly a lot of people were shifting completely to LLM, because data scientists are like attracted by the nice and shiny, by the new and shiny. I suffer from the same problem, right? I love, like, when there's a new cool technology to try and work with it. And when deep learning came out, suddenly, like, e- everything that you do, you have to do it with deep learning. And over the years, we've tried to apply deep learning to certain of our problems, you know, to realize that no, you know, stay with XGBoost. It gives you much better result. And Amitai Armon and Ravid Ziv from my department published a very well received paper on that issue. That you know tree-based approach, like, eat a neural network for breakfast on average, right? You can find a
Mm-hmm.
problem where with tabular data where deep learning is going to beat XGBoost, but on average it won't. Um,
XGBoost is all you need.
exactly. Um, so the again, in my department, we try and think of where is the biggest impact that we can give to our business partners, and we talk with them. We understand. We give them the opportunity. We say, okay, there's this new demand that you're telling us about your documents, and you want, a Q&A system. We can imagine something like that. Okay, let's assume that we give you that, but it will come at the cost of not doing this project. What is more critical for you?
Mm-hmm.
um, so some of our work is done this way, but not always, because there's the problem of faster horses. The business partners don't always have the foresight of what is actually possible, and then we take risks. And some project that we believe in, we would develop, and we would, you know, reduce resources in another project, or kill something that where we see we don't have a strong business partnership, and devote the resources there.
Fair enough. Yeah, just in case someone is listening and didn't understand the reference to faster horses, when people there's an interview with Ford, with Henry Ford, and he said that if he would have asked people what they wanted, they would have told him faster horses. So Henry Ford is in the founder of Ford. So the people don't always know what technology can enable, and they might think in sort of analog terms in the digital world and things like that. I agree that that's sort of one thing. The way I think about these things is that you need to interview people for sort of what they really need, but try to avoid asking them what they want. Uh, and so, if you can tease apart those two things, then you can figure out what will solve their needs best, because you have the sort of knowledge of the technologies that are available and how they can best be used and things like that.
Right.
But I totally agree with you. I guess the one of the things that I think I gave a talk about this a couple of weeks ago. I think that in the LLM world, the two hardest tasks are customizing the model and evaluating the model. I'm curious if you can share a bit about how you do those things in your group.
Sure. So we have different approaches on different use cases. Again, we're not set in our ways. So for certain projects, we actually, for most projects, we try and be opportunistic. Okay, let's develop a system. Let's get a feel of how it responds to the user queries. Okay, to what we want to do. At the end of the day, we want to do the minimal amount of work on a certain problem and deliver value to our customers. Here, our customers are the engineers at Intel. Why? Because there's a lot of other problems that we need to solve after this one. So usually we would build a system. So for instance, we built a Q&A system because it was new and we wanted to be able to work offline from customers, and we didn't necessarily have a good sense of what they would want. It was our first like big LLM project. There we worked with engineers to create like Q&As, okay, just as a test set, right? A few tens of questions, and obviously this enables you to accelerate development because then you work offline and you can get a very good idea of how you're doing on your benchmark, and it's much easier because you have to understand that most of the things that we will try to solve with our problems, I can't understand if the result is right or not. Right? I'm not
Mhm.
a validation expert, so it can be tricky. But in other spaces where you're trying to build a more complex system, you know you try, you get you show it to the customers, then you get some feedback. They say, no, we wanted to focus on that aspect, and the answer is not quite right, and we need to add another thing here, thing there. So you do a lot of customer feedback, and then we release a alpha version, right, with the very nice feedback button, and that's how you start to collect feedback in at scale. Okay, and then once you have that feedback, you can go and accelerate the development and do your prompt engineering, whether manually or automatically, and that's the positive spinning wheel.
So if I sort of repeat what you're saying in my words, basically what you're saying is that your approach is to get the first version into the hands of the users as fast as possible, and then try
Yeah,
to accelerate the development process using real world feedback from them.
yeah.
Okay, that makes a lot of sense. I think that this is this is the best practice whenever you can do it. I'm curious if there are also do you have like more reference based methods of evaluation? Do you use some metrics for these things, or is it mostly based on user feedback?
So again, it depends on the use case. For instance, if you're training a code completion model, right? Then you have very clear metrics that you can use, right? In this
Mm-hmm.
case, I don't need to wait for the users to give me feedback on do they like my code completion. It's important because that will tell me some information about the speed. Maybe is it too obtrusive and things like that. But I have very clear metrics of code completion where I can take code, do ablation studies, and say, okay, how good am I at predicting the next token, the next line, the next 20 line of that piece of code, right?
Mm-hmm.
Can I create the whole function from the description and so on and so forth? So in that case, that's one thing. Another thing that we did is like some of the project we had, we were able to create synthetic data, okay?
Mm-hmm.
Because we knew that this was a more generic problem, and you can take a piece of data that's correct and make it incorrect. And now you ask your system, okay, can you identify between if the data is correct or not? And there you go, you have a test. But again, you have to be very careful about synthetic data because usually it will reflect a skewed perception of reality, especially when you're trying to find, like, for instance, bug in code. You can create random bugs, but most of the bugs in reality aren't going to look at all like your random bugs, right? They're going to look,
Yes.
they're going to happen in very specific place. They're going to be a specific type of bug. And then again, your test set is going to be have a very different distribution from your actual real world scenario.
Yeah, no, that makes total sense. I think that if you have a well-defined problem where you can actually automatically generate test sets, like the code example, that's great. If you don't, then you're definitely in the harder region of problems that you're trying to solve, and then user feedback becomes more important. Uh,
Mm-hmm.
but yeah, but all of this makes total sense. I guess what tools are you using for the ML and the LLM projects? What are the main tools? Let's say.
Okay. Um, so for the LLM side, you know, we're using APIs to existing models. Uh, you know, the more relevant ones. Okay.
Sure.
I'll let you imagine which ones. And for the uh, local models, right? Models that we would either use out of the box, you know, for embedding of text, or even an embedding model that we fine tune for our needs. Then you can serve them, either originally I think we were using like Seldon clients,
Mm,
but then it wasn't stable enough. We moved to TGI inference. At some point you're trying to find what is the right standard. At the beginning, it was still like the Wild West. Everyone was had different ideas of how to serve the model in the best way. I think like Hugging Face are becoming the standards in terms of these interfaces in many
hmm.
ways.
You mean
Um,
Transformers?
the no, I'm talking about the Hugging Face serving mechanism like
Ah,
TGI.
okay, TGI. Yeah.
Yeah. In terms of databases for embedding, so again, there's a debate. Are you using like external server, open source? So we looked at different options. Milvus is a vector store that has been useful to us.
Hmm.
And like for a lot of the unstructured text, and we've got Elasticsearch, which is fantastic, scales perfectly. There's a lot of resource at Intel also to support it, and it was a clear choice for us. In terms of non-LLM projects, then wow, there's a wide variety. But as I said, like for instance, in my team we use Spark over a Hadoop cluster like CDH uh, and stuff like that, with Kafka and to do the message ingestion. And I'm not gonna take you through the whole architecture, but these are the main tools.
Hmm.
And then if you want to develop, then I give the choice in my team if you want to use PyCharm or VS Code. I tolerate Jupyter notebooks, um, but I think they're great if you want to do a training, or if you're like deep into error analysis. Unfortunately, people develop whole algorithms with Jupyter notebooks, which is very nice, but difficult to reproduce. And then when you have to go and productize your algorithm into the system, you're going to pay a premium of like extra, I'd say, weeks of work compared to if you develop your code, in a proper fashion in an IDE. Um, so I have my favorites.
Fair enough. Um, Last hard question before we get to the faster ones. And I know this one is maybe hardest. So if you had to choose one, what's the biggest challenge in your machine learning efforts or machine learning management efforts, and how do you solve it?
Change management, in the sense of when you have a system, ML system that you develop that's completely seamless to the customers, it's fine, right? When you have a system that requires a customer interaction and you require the customer to change the way he's doing his work, then you have to think very carefully, right? And here you can say, well, it's a product question. You're a data scientist. Why do you care? Well, I care because I want the engineers to use my tools, the tools that I
Mm-hmm.
develop. And here sometimes the secret is not in making a better algorithm, but is to build a better tool. There's a lot of talk on explainability. That's one thing, but sometimes it's also, even having the right UI, making the right embedding your solution within their existing tools.
Yeah.
But then it's difficult, more costly, right? You have to do a lot of engineering work before you can measure value. So there's a big trade-off that you have to walk that fine line.
Fair enough. It sounds like you still lean towards, though, having something that maybe is a bit more hacked together in the hands of the user fast and then iterating on that over investing a lot
Yeah,
of time
but
upfront.
so definitely start with a hacking. Put a customer in the room, but that I want to say is the easy part, because
Mm,
usually, you always find a few customers that are AI enthusiasts, and it's not let's say they're in the room with you because they're willing to listen to you to begin with. So it means they are slightly positively biased towards AI. That's what I find, at least. When you're going to take your tool and release it to a lot of people, you have, again, another distribution of people. And you have to understand, okay, will it translate well into the general population of the users? So hacking a solution together can be good at the beginning for those interviews, but when you create an alpha version of your tool, you need to understand what's the minimal amount of you know user interface. And user interface sometimes can be a txt file, right? We created once a debug report, and it's a completely txt file. At the beginning I had like dreams of UX and everything, and I understand that if I were to create a UX, like, with GUI and everything, they'll never use it. But the
mm-hmm.
right user interface for that case was create an insight report and place it in the directory where they have the failure logs, next to the failure logs. So when they enter the system, right, they can enter the log and start debugging. Okay, they can look at your report first and say, okay, is there an interesting insights here? Okay, now I've read it, I'll go into the log, and maybe I saved them, 5 seconds. Maybe I've saved them 20 minutes, or maybe I got to the root cause and I completely saved them a day's worth of work. So user interface or user experience here is very different from like a complex system, and so it doesn't always need to be, you know, create a nice and shiny GUI, but it's really understanding what is the minimal amount of change management that I need to do on their part for them to be willing to use my tool.
I really like that answer. That's great. I think the main takeaway for me from what you just said is that when we're building a product, we sometimes have a tendency to think about ourselves as the builders, and then say
Mm-hmm.
like, oh, we need to create this sophisticated UI for our product. But what it's actually about is the user. If the user wants to be in a folder where they have the logs, then that's where we need to provide them the value. Uh,
Right.
so I think that that's really great takeaway for a lot of people building. It's AI, it's shiny. It doesn't mean that the output needs to be a shiny UI necessarily.
Mm-hmm.
Um, So that's awesome. Let's do a few faster questions. So, what are you most excited about in the fields of machine learning and AI, and why?
Well, again, I said NLP. For me, NLP is really, I feel you can get to the essence of human understanding. Uh, it's a real whirlwind, and you don't know where it's going to take you. So thankfully, these past few months, the pace of release of new and amazing models has slowed down a little bit, so I can actually do some work.
From
But
once
yeah,
a
it's
day to once a week. Uh,
exactly.
fair enough. Um, what? So now to the spicy one. What? Tell me something that you think is true, but few people would agree with in the field of machine learning and AI.
I think the most interesting problems in machine learning involve small data.
Interesting. Okay. Can you give
Yeah,
an example?
yeah. So we have like, I spoke to you about the test where we have, hundreds of thousands of tests and you have to figure out stuff. But I have another team that I manage, and they work on problems where the tests are so long that they take like days or weeks to run. And so you can run only very small amount of configuration.
Mm-hmm.
And now you have to understand, okay, how can I learn from like, you know, 20 examples? What can I say? How can I do machine learning on that? But that's where the beauty lies, because now, when I told you, well, history is not relevant because, you know, the model changes so much. Well, I can't afford to not look at history anymore. I have to be
Mm-hmm.
able to get some information, to squeeze that lemon all the way. And it leads you like down very interesting machine learning rabbit holes. And the guys who are working on that, you're talking to them about LLM, they're like not interested. I'm doing really cool stuff at the moment.
Yeah, that's I like that. That's a good take. I think that when you have less data, that means it's harder to make like extrapolations from that data,
Hmm.
or interpolate that data, and that means that you need to work harder
Yeah.
to
Suddenly
get something useful.
suddenly the algorithm matter, right?
Yeah,
If you have a
yeah,
lot of
that's
data, well, XGBoost or random forest or regression, there are differences, but here, like, it's not just about what algorithm you're going to use, but what's your optimization function and how you calculate it, and it's really fun.
maybe this is a tip for people that like hard problems. Like if you're looking for a hard problem in ML, find a place where, by definition, you don't have a lot of data. Like
Absolutely,
that, it's a limit. So that's
but
nice.
high value.
High value. Sure, sure.
Like,
That's always
it's a
important.
problem. These are problems where if you improve the results by like 2-3%, huge impact.
Yeah, yeah, that makes sense. And last but not least, recommendations for the audience. It doesn't have to be related to data in machine learning.
Sure. Well, first of all, I love podcasts, so I constantly. Some of them are in Hebrew, so for the Hebrew listener, The Economy is always my go-to. But in English, everyone in the field, I guess, listen to Lex Friedman, and you can sample also from time to time Joe Rogan for a
Mhm.
completely different experience. I know you like fantasy books, so I
I
want to
do.
give a shout out to Steven Erickson, who is like, I think, my favorite fantasy author, the Malazan Book of the Fallen, which is an incredible epic. And I don't know, every couple of years I find myself rereading the entire series and discovering like new things. So I'm about to start a new reread soon.
I haven't
Um,
read that, so that's a good recommendation. I'll check
it's
it out.
brilliant.
I'm
It's
I'm looking
tough.
for my
It's
next book to read.
Yeah, no, it's a tough one to get into. I have to advise, caution advised, but it's brilliant.
Amazing. So I don't have any special recommendations this time. So with that, Jeremie, thank you so much for taking the time to speak with me today.
Thank you very much, Dean, for having me. And sorry about the camera troubles. Haven't
No.
been able to fix it, but you can imagine my pictures during our conversation.
We'll release this one without the video probably. But thank you so much. This was a pleasure. I learned a lot.
Thank you, Dean.
Thank you to the audience. I'll see you next time. Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.